Continuing our discussion of Chapter 8, Specialized Audit Tools, Sampling and Generalized Audit Software. Determining the objective of the test. In tests of controls, the objective boils down to a question. Are various controls for a particular class of transactions sufficiently effective to allow assessing control risk below maximum? We're testing to see if the controls together as a whole are sufficiently effective for us to assess the control risk below the maximum. For sales returns, for example, controls may include proper authorization. Companies require their customers to obtain authorization before they can send the merchandise back. Checking unit prices and extension. This is to make sure that we don't give the customers more credit than they deserve. Vouching details of the credit memos to source document. For instance, receiving report. So we got to make sure we give credit to the customers according to what they have actually returned. This example shows that the auditor may be interested in testing multiple attributes in some cases. We'll discuss the implications when we talk about the sample size determination in a few minutes. For each control that we test, we have to identify the attribute and also the deviation. Attribute simply means a characteristic of a control. Back to our example on the previous slide, one of the attributes is the quantities and other data on the credit memo agree with the receiving report. It's a yes or no. The attribute is either there or it's missing. If it's missing, it means there is a deviation. So if the quantities and other data on the credit memo disagree with the receiving report, we have a deviation condition. Now, the deviation condition has to be precisely defined, otherwise we will end up with non-sampling risk. Also, in attribute sampling, each item is a sampling unit. A deviation is a deviation. It doesn't matter the dollar amount of the item on which the deviation occurred. Every case represents deviation from prescribed policies and procedures. What attribute sampling method do we use? The book only talks about attribute sampling, but in reality there are other attribute sampling techniques. So I'm going to cover those in detail here. Depends on the nature of controls and then the expectations and or knowledge about the rate of deviation. We can choose from one of three methods. The most common one, the most commonly used, is what is known as attribute estimation or simply attribute sampling. But there's also discovery sampling and there is stop or go sampling. Let's talk about the sample selection and evaluation process under each of these methods. So let's start with attribute sampling. Attribute sampling is a statistical method that allows the auditor to estimate a true but unknown population deviation rate. So the objective here is to estimate the population deviation rate. In attribute sampling, the sample size is affected primarily by three factors: the allowable risk of over-reliance, tolerable rate, also known as acceptable upper error limit, and then the expected population deviation rate. Population size has little or no effect on the sample size. There is an adjustment factor for small populations, but really we don't consider the population size in attribute sampling because we normally take a minimum sample anyway. Let's talk about each of these three factors: the allowable risk of over-reliance, tolerable rate, and then the expected population deviation rate. Now, we talked about the risk of over-reliance. That risk, remember, is unknown. So we're now talking about what we, as the auditor, would allow. The risk of over-reliance, we said, is the risk of assessing control risk at less than its actual level. So we assess the risk in our example as moderate, but the risk in fact is high. Now, when we say we allow for a 5% risk of over-reliance, that means we are only willing to accept a 5% chance of assessing control risk lower than its actual level. 5% chance of making a type 2 beta error. 5% chance of over-relying on internal control. So hash this out and make sure you understand every way that I have stated this. To state this differently, in fact, we would say that we are 95% confident. We have a 95% reliability level that we have not over-relied on internal control, that we have not assessed the control risk at less than its actual level. So again, make a distinction between the risk of over-reliance and then the allowable, what we would accept as risk of over-relying on internal control. So what is tolerable rate? Tolerable rate is the maximum rate of deviation that the auditor would accept without altering, without changing the planned assessed level of control risk. An alternative explanation of tolerable rate is the deviation rate that would lead to the conclusion that the control failure would constitute a significant deficiency or a material weakness. Tolerable rate, also again known as acceptable upper limit, is normally set at less than 10% unless the auditor has assessed the control risk at maximum. So what about the expected population deviation rate? This is the rate that the auditor expects to see in the population based on the judgment, based on prior knowledge, and if this is a new client or a new environment or the environment has changed, a pilot sample of 50 or 60 items to estimate the expected population deviation rate. Remember, we said if the sample is representative of the population, that it has about the same characteristics. So if we take a sample of 50 or 60 item, a pilot sample, and determine the rate of deviation, that is also the estimated population deviation rate. How do we determine the sample size in attribute sampling? There are computer programs, the generalized audit software, or other programs that would calculate the sample size for us based on the input that we give it of the allowable risk of over-reliance, etc. There are also tables. So Exhibit 8.5 in your book is what we are going to use to determine the sample size for attribute sampling. Now remember, there were three factors that affected the sample size essentially in attribute sampling. So open your book, look at Exhibit 8.5. There are two tables built in that exhibit. Table 1 on the top, it says 5% risk of over-reliance. Table 2 says 10% risk of over-reliance, risk of assessing control risk too low. So out of the three factors, we took one out. The other two are the columns and the rows. So the columns are the tolerable deviation rate, and then the rows are the expected population deviation rate. The cell entries simply show the sample sizes for different tolerable rates and expected population deviation rate. For example, if we allow for 5% risk of over-reliance, which means we're going to look at Table 1 in Exhibit 8.5, and if we have set the tolerable rate at 4% and we expect a 1% deviation rate in the population, then our sample size would be 156. So that's the intersection of the 4% tolerable rate and the 1% expected population deviation rate. The numbers in the bracket you can throw out. Those are the expected number of deviations. That's simply 156 in this case times the 1% rounded is 2. We cannot have 1.56 errors for deviation. It's either 1 deviation or 2 deviations that we expect. So that's how we determine the sample size. So we take 156 credit memos and we're going to test them for the attribute. Check to see if the attributes are present or if we have deviations. Before we go to how we evaluate the sample results based on how many deviations we find, let's talk about a possibility of looking for the credit memo. Either the credit memo is not there or the supporting document, the receiving report, is not there. What do we do? These are called unexaminable sample item. If the auditor is unable to apply the audit test, then in tests of controls, the auditor is going to have to say that is a deviation because we don't see the attribute there. If we have a deviation, then that might affect the assessed level of control risk and increase substantive testing. So let's talk about the sample evaluation now. How do we evaluate the sample? Computer programs or tables can be used to evaluate the sample results as well. Now we could potentially use Exhibit 8.5 for sample evaluation, but that is not a good idea. There are other tables, so there is Exhibit 8.6, and again you have two tables in here. One is the 5% risk of over-reliance. Table 2 on the next page is 10%. In our example, we had 5% risk of over-reliance, so we're going to look at Table 1 again. This Exhibit 8.6 is essentially the same way as Exhibit 8.5. Now the columns here are the actual number of deviations found, and the rows are the sample sizes. Our sample size was 156. Clearly, there is no 156. Computers don't have this problem, but tables do. There's 150, and then there is 200. We will look to see what we do in just a second. 150, let's look at that row. And let's assume that when we took the 156 items as our sample and tested for deviations, that we found, in fact, 3 deviations. So if we found 3 deviations, we're looking at Table 1, Exhibit 8.6, on the 3 deviations found column and the row of 150, and we see 5.1. What is the 5.1? This is called the upper limit, not the allowable or the tolerable, but the actual or achieved upper error limit, also known as maximum population deviation rate. So we say in this case, with these numbers that we have, that we are 95% confident. Why do I say 95% confident or at a reliability level of 95%? Because the risk is set at 5%. 1 minus the beta is the reliability or the confidence level. So we are 95% confident that the maximum population deviation rate, or the upper limit on the error, is less than or equal to 5.1. Now look, if we go down to the row that says 200 as the sample size, that goes down to 3.9%. Do not interpolate. This is not something you want to do that. You want to stay on the conservative side. So the 5.1 is better than the 3.9 in most auditors' judgment. That's what we're going to stick to. So we're going to compare this maximum deviation rate, or the upper limit, to the tolerable rate. In our example, the tolerable rate was 4%. So tolerable rate is 4%. The upper limit with my example is 5.1%, and that means the test does not support the auditor's planned assessed level of control risk. We have to increase the assessed level of control risk. We'll talk about the odds and ends in just a second. However, if on the same sample of 156 items, I only detected one deviation, then looking at the same exhibit, Exhibit 8.6, the maximum population deviation rate, or the upper limit, is only 3.2%, in which case the upper limit is less than the tolerable rate, and the test therefore would support the auditor's planned assessed level of control risk. So make sure you understand what you are comparing. The upper limit, also known as the maximum population deviation rate, with the tolerable rate. If you don't understand this, go back and listen to it again. Read the text. Make sure you understand. This is really important. So what do we do in my first example? The maximum population deviation rate is 5.1%, and we were only willing to tolerate a 4% error rate. We got to test compensating controls. Increase the control risk level from the moderate, as we had assessed originally, to maximum. Decide, in fact, whether the control failures represent significant deficiencies or material weaknesses, and potentially adjust substantive tests, meaning if we increase the level of control risk, we're going to have to do more testing. Clearly, in addition to evaluating the results of the sample quantitatively, the auditor considers qualitative aspects of the control failures as well. For example, are the sample results caused by errors, or do they indicate the possibility of fraud? We'll address the qualitative factors on the next slide. Furthermore, we cannot base our conclusion strictly on the statistical sample results, especially when the sample size is small. We have to look at the evidence from other tests of controls, whether that's inquiries of personnel, observation of application of control policies, etc. So let's look at the qualitative